This is GCSE Further Maths. We are in Unit 2, Resolving Forces and Newton's Laws, and we're just doing some final past paper type questions. So I've already kind of halfway through this, so I'll just talk you through it. A block of mass 4 kilograms is pulled up a slope inclined to the horizontal at an angle of 25 degrees by a force of 30 newtons as shown in the diagram below. The resistance of motion due to friction is 10 newtons. Mark on the diagram above all the other forces acting on the block. So I've added in a normal reaction going this way here. I've added in the 4G acting down. I've added in the 10 newtons, which is the friction, because if it's going this way, then the friction is going to be acting in the opposite direction. Calculate the acceleration of the block up the slope. Give your answer correct to 2 decimal places. So this way here, there's no R. It doesn't actually work to ask you to work out R, but we worked out R anyway. But there's no movement, so it's in equilibrium. R equals 4G cos 25. Good practice to do anyway. For this one, we've F equals MA. So what do we have going this direction here? 30, take away 10, take away 4G sine slope. So 4G sine 25. So that's what I've written here. 30, take away 10, take away 4G sine 25 equals 4A. Put that into your calculator, 3.09527 equals 4A, and then that gives you A is 0.77 meters per second squared. That's the 2 decimal places. There's another part then to this question, and we need to take a wee look then at this. So the 30 Newton force that was pulling it up the slope is removed, and the block continues to move up the slope before coming to instantaneous rest at the point A. So it goes on up and stops at A, and then starts to slide down the slope. The resistance to motion caused by friction remains at 10 newtons. By redrawing the diagram, I don't like the or otherwise, I would definitely want to see a diagram drawn, that's okay. Calculate how far the block will have moved 2 seconds after leaving the point A, giving your answer to 2 decimal places. So it's now going to start accelerating down the slope again, and we need to find a new acceleration and work then from there. So let's do some calculations then. Okay, so what's going on? So we think it's going to start sliding down the slope with 10 going this way, so we're going to do F equals MA. So what's bringing it down the slope? It's actually this 4G, so it's going to be 4G sine 25 take away 10 equals mass times acceleration, so it's going to be 4A. If we put this into our calculator, we get then 6.9047, that's just a number, equals 4A, and my A then is 1.72618. It doesn't ask us for acceleration here, so we have that, so A is 1.76 once you divide then by 4. So we're going to now use UVAST to find out how far the block will have moved 2 seconds after leaving the point A. So U, V, A, S, and T. U is 0, V we don't know, A is 1.72618. S we're trying to work out, and our time is 2. So in this case we would use S equals UT plus a half AT squared. S equals 0 upon 2 plus a half 1.72618 upon 2 squared. That gives us 0, half upon, I guess the 4 gives me 2, so if I times that by 2, and I'm going to S is 3.452. So the distance travelled in the 2 decimal places equals 3.45 meters, and that's the 2 decimal places.